Hello, ladies, gentlemen, and in between, and welcome back to another episode of Maths with Hamblin with your beautiful host, Hamblin. And today we're going to start our journey with studying polynomial functions with quadratics, and we're going to learn how to solve them, which I mean solve for their roots, by one of three methods that I'm going to show you during this chapter, which is factorization. Now, I know you probably know what factorization is already, but it's just nice to go over some review. So let's do it, boys. Okay, so first, what do I mean by solving a quadratic and solving for the roots? Well, so I'm just going to ask you to look at this quadratic. It doesn't matter that specific one I've chosen, just any old quadratic polynomial function. And what the roots are is, if I set this equal to 0 here, the roots are the numbers that you can chuck into the function such that this whole thing equals 0. So the numbers that make the function 0. Now, solving for the roots, usually, I mean, look at this thing. That's going to be quite hard. You can't really do any algebraic process just yet to solve that. But there is a certain type of quadratic polynomial we can solve quite easily, and I'll show you what that looks like. So consider some quadratic polynomial function that looks kind of strange like this. Now that might not look at first like a quadratic polynomial, but it actually is. It's in disguise. If you expand out these brackets, you'll see that it actually is a quadratic polynomial, because you'll get an x squared and you'll get some terms with x, and then you'll get a constant added on the end. So this actually is a quadratic polynomial, but the really good thing about it is that it's really easy to solve for the roots, and I'll show you how. So if you want to solve for the roots, we're going to solve for the numbers such that it equals 0. So let's set it equal to 0 and see what we can do. But something very special has happened here, my boys. If you look, we've got this product here times this product here, and the whole thing equals 0. Now recall that if you have something times 0, it equals 0. So for this product to equal 0, either one of these, and what's called factors, by the way, when you have a polynomial written as these two brackets, they're called factors. One of these factors must be equal to 0 to crush the whole thing down to 0. So this is great. We can conclude that for this whole thing to be true, either x minus 7 must equal 0, or x plus 1 must equal 0. And from here, my boys, we can quite easily get the roots, right? This implies that x equals 7, and this implies that x equals negative 1. So look at that. If our quadratic polynomial is written in this really nice and easy form, then we can just set one of them equal to 0, or set both of them equal to 0, and get the roots nice and easy. So in conclusion, we've solved for the roots of this quadratic polynomial, remembering that the roots are the numbers such that you chuck it into the quadratic polynomial function. God, I love saying that phrase. Makes me feel so smart. Such that it equals 0. But that's not usual, right? And most of the time you'll get something like this. You won't get that. But there's a way we can figure out how to write some quadratics like this, and I'll show you how just in a sec. Okay, my boys, so to figure out how we can write any quadratic polynomial as a nice product of two factors, I'm going to ask you to take a look at this specific example here. So what we're going to want to do is figure out through some process how we can turn it into a product of two factors. So I'm going to say that this function equals x plus some number times x plus some other number. And what we're going to try and do is figure out a and b. And I'm sure you can see this is quite an easy thing to do. If we expand out the brackets, you'll see something magical will happen. So if we expand out the brackets, we're going to get some x squared, then we're going to get b times x, we're going to get a times x, and then we're going to get a trailing little ab on the end. Now I can factor out the x. Boom, there we go. And look what we see here. So if we want this function to be identical to this function so that we can find the roots, all we need is that b plus a to be equal to negative 7 and a times b equal to 6. Now contemplate why that is true for a second. For this function to be equal to this function for any value of x, which is what we want, our two mystery numbers here that we want to shove into the factors, their sum must be negative 7 and their multiplication must be 6. Now that is pretty cool. We can figure out how to do this factorization just by looking at the numbers here. Now, I'm going to write down those conditions here. So a plus b is negative 7 and ab is 6. Let's just think for a second what a and b could be, given that their sum is negative 7 and their multiplication is 6. Well, if we think for a second, negative 6 and 1 would satisfy that property, right? Negative 6 minus 1, that's just 7, and negative 6 times negative 1 is 6. So we've figured out, if we want this to be identical to this function so we can find the roots, A should equal -6 and B should equal -1. So we figured out that this quadratic polynomial is identical to this quadratic polynomial. But now this is really useful because if we want to find the roots, so we set it equal to 0, this is really great, right? We can just look at either one of these factors and think, well, one of them must be equal to 0. So either x equals 6 or x equals 1. So boom. And what we've done there is called factorisation, because we've turned this nasty, unexpanded quadratic polynomial into a nice product of two factors. And there we can find the roots, remembering that the roots are the numbers that you input into the function and it equals 0. Now, that was kind of an easy case. Let's look at a harder case. Okay, so my boys, now let's take a look at a bit of a harder example. Now, consider this function here, this quadratic function, and let's say we're trying to find the roots of this function. Now, if we try and use the method we've learned, factorisation, we're going to run into a bit of a problem, and we'll see why just now. So let's say we want to write this equivalently as x plus something times x plus something. I've left those blanks, don't worry about it. But take a look what happens. If we expand this, we're going to get x squared and then dot, 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 dot. No matter what numbers we choose here, no matter what numbers we figure out, these functions are never actually going to be equal to each other because we've got this trailing x squared in the front. However, in this function we're actually trying to find the roots of, we've got a 3x squared. And you can see, hopefully, that no matter what numbers we choose here, we're never actually going to get an equivalent form for our function because we're going to have this x squared instead of this 3x squared. So factorisation, what we've learned previously, isn't going to make the cut. But there's an easy fix. If instead we try and write one of these linear factors here as 3x plus something times x plus something, this problem will disappear because when we expand this we'll get a 3x squared and dot 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 dot. So it will be possible for us to write it as 3x plus something times x plus something. So if let's just go figure that out. So if I put plus a plus b here, and let's do the same process we did before. If I expand this out quickly, we get 3x squared plus 3bx plus ax plus ab. And just like before, we can factor this baby out. We're going to get x times 3b plus a and then plus ab. And now, my boys, we can play the exact same game we did before. Compare these coefficients here and see what conditions arise. And we see that for these two functions to be the same, 3b plus a, well, that's got to be the same as 5. And a times b must equal -2. So what we're actually doing here is we're playing the exact same game as before, but it's just a little bit harder. We've got 3b plus a instead of just a plus b. So I'm going to rearrange this information in a table, and then I'm going to teach you what's called the peanut method to make this nice and easy. So rearranging this in a table, we've got 3 times something, 3 times another thing, and that will equal 2 things, we don't know, but we're hoping that they'll sum to be 5. And now, this is called the peanut method. We're going to think what 2 numbers will satisfy this property, given that they have to multiply to -2. And if you think about it for a second, what are the only two, there's only a few possible combinations of integers, a and b, where they multiply to -2. You can have -2 and 1, or -1 and 2. So we can just try each combination and figure it out. So if we try, say, for example, +2 and -1, those will still multiply to -2. We'll get a 6 out here, and we'll get, oh, I meant to have this as a 1, I'm terribly sorry. And this will be a -1, and they'll sum to 5, which is beautiful. So even when we haven't got a 1 in front of the x squared, we've still been able to figure out how to do this process. And if I just replace the numbers up here with what they are, and by the way, sorry, the peanut method, the main point of it is then when you're finished, you cross these lines here, and then you can figure out that 3 must be paired with -1, and that 1 must be paired with 2. So chuck those in the brackets, and boom, we've rewritten this function as a product of 2 factors, which makes it really easy to solve. So if I set it equal to 0 to find the roots of the function, we get, I'm going to write it down here, sorry, x, well, if you do a little bit of mental maths here, you get x is 1/3, ugh, nice, not a nice rational number, and then here you get x equals -2. So, boom, my boys, that is how you solve some quadratic polynomials, because you'll see this method won't really work for some quadratics. In fact, most quadratics it won't work. and in the next few episodes we'll learn another method. So in conclusion, if you want to solve a quadratic polynomial, we want to solve for its roots by factorization, we just have to figure out how to write it as a product of two linear factors, and we can do that by looking at the coefficients and thinking what two numbers add to this and multiply to this, or in the case where you've got not a 1 in front of the x squared, then you have to be a bit more clever about it and use the Peanut method. So I'm going to go through some examples next time, but as always, bros, thanks for watching, and please consider subscribing. I'm very desperate. I'm a very poor boy. I need that cash money. Anyway, thanks for watching, boys. See you in the next one.